You're standing in front of the sink. You pull the plug and watch as the water disappears in a circle. A small vortex forms, spinning, hypnotic, like a mini galaxy in your bathroom. And while you're standing there, completely fascinated by this miniature water tornado, you remember something someone once told you. In the Northern Hemisphere, water always spins clockwise. In the Southern Hemisphere, counterclockwise. Because of Earth's rotation. Of course! That sounds logical, sounds scientific. The Earth rotates, so your drain water rotates too. Makes total sense. So logical that you've probably even repeated it before. Probably at a party to sound smart. But the truth is, your drain has no idea which hemisphere it's on. It cares about Earth rotation as much as a goldfish cares about quantum physics. Earth rotation does actually influence huge systems like hurricanes or ocean currents. But your sink? That dances to its own tune. And this is where one of the most persistent, most charming myths in everyday physics begins. Welcome back to the channel. Today we're looking at why water spins down the drain, what that really has to do with Earth, and why the truth is more complicated than most people think. Okay, it's true that Earth's rotation does actually influence how water spins. Sort of. Because that only applies to massive systems like hurricanes or ocean currents. But your drain? It couldn't care less about Earth's rotation. And this is where one of the most persistent myths in everyday physics begins. Let's start with what's actually true. The Coriolis force. It's real, measurable, and has an enormous influence on our planet. Earth rotates, once every 24 hours, around its own axis. At the equator, the surface moves at about 1,040 miles per hour. At the poles, it's practically standing still. That means different points on Earth have different speeds. When something now moves over large distances, a plane, an ocean current, or an air mass, it doesn't simply move in a straight line. From the perspective of the rotating Earth, it appears to move sideways, to the right in the Northern Hemisphere, to the left in the Southern Hemisphere. That's the Coriolis force. Not a real force in the physical sense, but an effect of Earth's rotation, a so-called fictitious force. And this force has massive impacts. It's the reason why hurricanes rotate counterclockwise in the Northern Hemisphere and clockwise in the Southern Hemisphere. Warm air rises, cool air flows in, and as these air masses travel over hundreds of miles, the Coriolis force deflects them to the side. Over hours and days, a massive vortex forms, a rotating system that can be thousands of miles wide. Ocean currents follow this pattern too. The Gulf Stream, the Great Oceanic Gyres, they all rotate in characteristic directions due to the Coriolis force. Clockwise in the Northern Hemisphere, counterclockwise in the Southern Hemisphere. That's science, that's measurable, that's reality. But here comes the crucial point. The Coriolis force only affects very large systems over very long time periods. A hurricane is hundreds of miles wide and exists for days. An ocean current extends across oceans and continents. Your sink is 16 inches wide and the water is gone in 10 seconds. The Coriolis force on the water in your drain is about as strong as the flap of a fly's wing on the other side of town. Theoretically present, practically absolutely irrelevant. To put it in numbers, the deflection from the Coriolis force in an average sink is in the range of micrometers. That's less than the thickness of a human hair. So why does the water in your drain spin at all? The answer is surprisingly mundane. Because it already had minimal rotation beforehand. And this rotation has nothing to do with Earth's rotation, but with 100 little coincidences. Maybe you filled the basin at an angle and the water came out of the faucet with a slight twist. Maybe there was a slight current when you washed your hands. Maybe the water wasn't perfectly still before you pulled the plug. Maybe a tiny air movement in the room nudged the water. Or maybe the asymmetric shape of your sink predetermined a preferred direction from the start. This tiny initial movement, barely visible, gets amplified as soon as the water drains. Because the closer the water gets to the drain, the faster it has to move to fit through the small hole. And if it's spinning even just a little bit, that spin gets faster and faster. Like a figure skater who pulls in her arms and suddenly rotates like a top. Physicists call this conservation of angular momentum. Imagine you're sitting on a swivel chair with your arms stretched out. Someone gives you a little push and you rotate slowly. Now you pull your arms to your body. Suddenly you're rotating much faster, even though no new force was added. That's exactly what happens with the water. The smaller the radius, the faster the rotation. From a barely noticeable swirl becomes a visible vortex. And now comes the really interesting part. The shape of your sink, the position of the drain, even tiny scratches or irregularities can massively influence which direction the water spins. Some basins have a slight tilt that preferentially directs water in one direction. Others have asymmetric drains that predetermine a rotation from the start. Even the way the pipes run under the basin can have an influence. That's why your sink can spin clockwise today and counterclockwise tomorrow. It's not about the Earth, not about planetary forces, but about how you filled, used, and emptied the basin. Every use is a small experiment with slightly different initial conditions. But wait, there are those famous videos where people stand right at the equator and the water spins left on one side, right 2 meters away. Tourists marvel, pay money, film it for Instagram. Show effect or science? Mostly show effect. The sellers of these experiments are masters of subtle manipulation. They know exactly how to nudge the water slightly when pouring it so it spins in the desired direction. A slight swing when pouring, a certain tilt of the bucket, and boom! The water has the desired initial rotation. The equator itself isn't the issue, but the preparation. That doesn't mean these people are lying. They're actually demonstrating a physical principle, namely the amplification of initial rotations. But they're selling it as proof of the Coriolis force. And that's the trick. Real scientific experiments on the Coriolis force in drains do actually exist. The most famous was conducted in 1962 by Asher Shapiro at MIT. He built a perfectly symmetric round basin, let the water sit absolutely still for 24 hours, eliminated every vibration, every air movement, every disturbance. Then, and only then, a minimal but measurable effect of the Coriolis force showed up. But that's laboratory work under extreme conditions, not everyday physics. Your bathroom isn't a clean room, your sink isn't perfectly symmetric, and you don't wait 24 hours before pulling the plug. And here lies the beauty of it all. The Coriolis force is real and powerful, but only on the large scale. It shapes weather, directs oceans, influences airplane navigation. It's one of the reasons why our planet works the way it works. But it's not omnipotent. It can steer a hurricane, but not your drain. This shows us something important about physics. Some forces only play a role on certain scales. In the universe, gravity dominates. In the atom, quantum mechanics. And in the sink, coincidences, geometry, and the whims of the moment dominate. So next time someone claims your drain proves Earth's rotation, you can smile and say, almost. Earth's rotation is real and shapes hurricanes. But my sink only proves that I put a slight counterclockwise spin into the water when I washed my hands. Because nature is large and powerful, but your bathroom is too small for its big tricks. And sometimes the small is just as fascinating as the large, just for different reasons. So stay curious, and if you like myths like this, subscribe to the channel, because this is where your curiosity gets satisfied. And if you sometimes wonder why you forget why you entered a room, or why cats always land on their feet, you'll find the answers in these videos. Enjoy!